All right, let's get right into it. Today we're tackling one of the biggest headaches in AI right now. How do you actually deploy your large language model? We're going to look at three of the heavyweights in the game: TGI, vLLM, and llama.cpp. By the end, you'll know exactly which one to bet on for your project.
So picture this. You've spent all this time and money training a phenomenal AI model. It's ready to go, but then you try to put it into production and you just hit a brick wall. It's way, way harder than it looks. So what's the deal? Why is this so difficult?
It really boils down to one word: memory. These LLMs, they are just unbelievably hungry for VRAM. And how they manage that memory when they're actually running what we call inference, that can mean the difference between an app that flies and one that just fails.
Okay, so here's how we're going to break it all down. First, we'll dig into that core deployment challenge. Then, we'll introduce our three main contenders: TGI, which I'm calling the enterprise workhorse, vLLM, the throughput king, and llama.cpp, the resourceful maverick. And finally, we'll throw them into the ring together to help you pick your winner.
So the single biggest bottleneck when you're running an LLM, it's not always the raw number crunching. It's managing something called the KV cache. This is basically the model's short-term memory, where it stores key info about what it's generating. Now, if you have long conversations or tons of people using it at once, this cache can blow up and eat every last bit of your GPU memory.
First up, we've got Text Generation Inference, or TGI, from the folks at Hugging Face. You should think of TGI as the big, reliable, heavy-duty truck of LLM serving. It's built for one main thing: being absolutely rock-solid in production.
See, TGI is made for big companies, for enterprises that simply can't afford any surprises. Its whole design is about giving you consistent, predictable performance. You know it's going to stay stable and responsive, even when it's getting hammered with requests. So what's TGI's secret weapon? It's something called FlashAttention 2. The best way to think about it is like this. Imagine your GPU's main memory is a big, slow storage room way down the hall. And its fast cache, the SRAM, is your workshop right beside you. Instead of running back and forth to the storage room for every single little tool, FlashAttention just brings the whole toolbox into the workshop at once. It's one trip. That seriously cuts down on memory bottlenecks and makes everything way more efficient.
And this is exactly why we call it the enterprise workhorse. It just comes with the whole toolkit right out of the box. You get native Kubernetes support, monitoring all set up, automatic scaling, plus a whole bunch of safety and logging features. It's the full package, ready for serious, large-scale work.
Okay, now let's switch gears completely. If TGI is that stable, heavy-duty truck, then our next contender, vLLM, is a Formula One race car. It is built for one thing above all else: pure, unadulterated speed. It's all about maximizing raw throughput.
But here's the cool thing about vLLM. Its whole philosophy is to give you that incredible blistering speed without forcing you into some rigid lockdown system. It's super flexible and really friendly for developers, which is why you see so many startups and research teams absolutely loving it.
So how in the world does it get that speed? Well, vLLM's secret weapon is called PagedAttention, and it is brilliant. It basically treats that giant KV cache on the GPU the same way your computer's operating system treats RAM. So instead of needing one huge, continuous chunk of memory for our requests, it breaks it up into smaller pages. This lets it pack way more requests onto the GPU, it gets rid of wasted space, and it can even share memory between requests. It's just a totally revolutionary way to handle memory.
And the results are, well, they're just staggering. Because of PagedAttention, vLLM can crank out up to 24 times the throughput of older methods. 24 times. For anything that has a ton of users at once, like a public chatbot, that is an absolute game changer, no question. And its whole deployment style reflects this focus on flexibility, right? It's Python first, it can act as a drop-in replacement for the OpenAI API, which is amazing, and it plays really nicely with tools like Ray if you need to scale out. It's all about putting power and control in the developer's hands.
And that brings us to our final contender, a true maverick in this space, llama.cpp. This project really started from a simple but kind of a radical idea. What if you didn't need a giant, crazy expensive GPU server to run a powerful language model?
And that right there is the core mission of llama.cpp. It's this incredibly optimized C++ library that's built to run LLMs really, really efficiently on just about anything. We're talking your laptop, maybe even your phone. It's amazing on CPUs, but can also use a GPU if you have one.
So what's its secret weapon? It's a technique called quantization. Okay, think of it like this. You have a massive, super high-resolution photo file. Quantization is like compressing that photo into a much smaller JPEG. It reduces the precision of the model's internal numbers, its weights, from say 32 bits down to maybe 8 or even 4. This shrinks the model's size and memory usage a lot. And the crazy part is, it has a surprisingly small impact on performance. What's just amazing about it is the simplicity. Seriously, there are no crazy dependencies to install. You basically just clone the code from GitHub, you build it, and you run it. That's it. This super lightweight, portable design makes it perfect for running models on your own machine, on edge devices, anywhere that resources are tight. Okay, we've met our 3 champions. Now it's time for the final showdown. Let's put them all side by side so you can figure out which one is the right tool for your job. Let's just break this down nice and simple. TGI's game is stability, using flash attention for big enterprise jobs. vLLM with PagedAttention is the undisputed king of raw throughput for busy APIs. And then you have llama.cpp, using quantization to be incredibly portable and efficient on just about any hardware. Their strengths, their use cases, they really couldn't be more different. So here's the easiest way to think about it. If you're building a fortress, something that needs to be rock solid, super secure, and predictable for a big company, you go with TGI. If you're building a racetrack and you need maximum speed and throughput for a public service, vLLM is your champion, hands down. And if you need a Swiss Army knife, something that's portable, efficient, and can just run anywhere, well, llama.cpp is the undeniable winner.
You know, at the end of the day, there isn't one best framework here. It all comes back to this. The real winner of this showdown isn't the one that looks best on a benchmark chart. It's the one that perfectly fits what your project actually needs. Your goals, your constraints, your environment. So as you start planning your next deployment, just ask yourself, what am I really building here? Is it a fortress, a racetrack, or a Swiss Army knife? The choice is yours.